It's time for your weekly boiler tip.
On this week's boiler tip, we're going to talk a little bit about conductivity. Water treatment and boilers go hand in hand. Your boiler's not going to last without water treatment, and conductivity plays an important role in maintaining your boiler. There are lots of impacts of poor conductivity control, which we'll discuss. But first, I just want to take a look at some of the components you may see on a boiler pertaining to conductivity control. One is bottom blowdown. So this is a flash steam generator, and it's got a bottom blowdown on it. Bottom blowdown is one way that we can control conductivity, but to be the most effective and efficient, an automated system is optimal. It's not mandatory. We could just use a needle valve and take samples and make adjustments, but a system like this will take samples automatically at intervals, and it will adjust the conductivity accordingly. So if we're going to control conductivity on a boiler, the first thing we need to do is measure it, so we know the value of the conductivity in the boiler. And the unit we often use for that is microsiemens. It's a resistance unit, and basically the more dissolved solids we have in the boiler, the higher the conductivity will be. So a simple tester can tell us what our conductivity is in the boiler or incoming water. And so if I read this is a freshwater sample out of our softener. Conductivity is about 400. So if we've got incoming water to our system at 400 microsiemens, our feed tank is not going to be lower than that if we've got 100% makeup on our water. We'll get a little bit more into that. That water is pumped into the boiler. So when we initially fill a boiler, we're going to have that 400 microsiemens of conductivity. Is that too high? Is it too low? Well, we really can't get any lower than that with this feed water, and it is on the low end. What's the issue with low conductivity? Nothing initially. It's just that we expect it to rise. And the reason we expect it to rise is as we boil steam or boil that water and send steam out in the system, all the TDS that's in the boiler stays in the boiler. So by the time we've run the full volume of the boiler out into the steam system, we've refilled it. So what we've got is that initial conductivity plus the conductivity we added with the makeup water. We run it more and the conductivity goes up again. So that process of adding water to the boiler and the steam leaving but not the total dissolved solids is called cycling. And so in this case, we filled the boiler and we've run it long enough to refill it a couple more times. And so that boiler is in the process of what we call cycling up. And at some point, there's a limit to how high we can allow a boiler to cycle. We'll talk some troubleshooting about that. If your boiler doesn't cycle up, and you are generating steam and sending it into the system, there's really only a couple ways that water could be leaving, because essentially steam's leaving into the system that's pure. That condensate coming back from the steam system is usually less than 25 microsiemens of conductivity because it's distilled water because it was steamed and condensed. So eventually our feed tank number could come down a little bit, but our boiler really won't. The only way it can is if water's discharged from it. So in a simple system, we would have a skimmer tube with a valve, and we would throttle that. And what that skimmer is going to do is basically throw away some of that water, because it's like gravy getting thicker on the stove. The only way to make that gravy thinner is to add more milk to it, but we don't want to overfill the boiler, so we have to skim some of that water so that the conductivity will come down over time. If the conductivity never comes up, that valve may be left wide open. Somebody may think, hey, that valve needs to be open, and it doesn't. That valve needs to be throttled like a very slow steering wheel. And as we see our cycles coming up and we approach the limit on the boiler, we're going to start throttling that open, continue to test at intervals, and try to control that. Now, where do we want to control that conductivity at? Generally on a fire tube boiler, between 3,500 and 4,000. That's sort of the high end of the conductivity range. But if it doesn't come up at all and that valve's not open, we've got water leaving, it's just not leaving where we think. We may have a bottom blowdown valve that is bleeding through, and a really simple way to test that is close all those valves, make sure they're in the closed position, let it run for a couple hours, and then shoot with a temperature gun those possible outlets where water could be leaving the boiler. Because basically, if we've got makeup water with conductivity in it, the boiler conductivity is only going to be going up. The drawback of running lower than our target conductivity is really that we're just sending water to drain, and that water's hot, and there's really no reason to get rid of it. So I've never seen a boiler damaged or perform poorly because of low conductivity. Typically, you're just going to have high chemical costs and high energy costs because those are things that we're putting into the water, and if the usage of that water is not getting maximized, we're spending that over and over again. Now, we often see conductivity that's too high. And basically, any boiler, based on its design, has sort of a limit to where we want to run the conductivity. Yeah, I'd love to use that water forever and not waste any of that energy, but the fact of the matter is we'll start having issues with the water level, and we can start having issues with corrosion if the conductivity is too high. Essentially, high conductivity causes foam on the water surface. If you take a pot of water, freshly filled from the sink, and you boil that on the stove, it doesn't boil over. You throw spaghetti in there, the starches seep into that water, they're dissolved and become dissolved solids. Now the pot foams and spills over. Well, the same thing can happen with a boiler. We call that carryover because there's only a little bit of space for the steam to separate from the bubbles and for the bubbles to pop and burst and the steam to travel out. If those bubbles don't pop promptly, we'll actually get a vortex of water and foam going out into the steam system. And a really easy way to test for that is to test that condensate return. Because if we're carrying solids out, that's going to be coming back. So getting a sample from a drip leg or a condensate receiver out in the system, if we see that number spike, that's going to indicate that we have carryover. It may be intermittent because at low loads, we have lower steam velocity leaving the boiler, carryover is less likely. But when we have peak demand, we're running the boiler hard or we're dropping the pressure on the boiler because of system demands, we're more likely to have carryover. So if you're monitoring that, check it during your highest load to make sure that you're not getting carryover. So if we detect carryover and we check our boiler water and our conductivity is high, essentially we need to get rid of some of that water. One way we can do it is with the bottom blowdown. But the issue with that is the bottom blowdown is not something that we can leave cracked unsupervised. It's something that we have to do this blowdown and then close it and come back and do it again. The surface skimmer is allowed to run continuously because we can throttle that, and basically because the skimmer outlet is above the heat exchanger in the boiler. So there's no way we can drain the boiler accidentally by skimming too much. High conductivity, we're getting carryover. We can do some blowdowns. We can check for blockage on that skimmer line, and we may need to check calibrations if we've got an automatic conductivity control. Because what we have to remember is there's a probe in there and it's measuring the resistance of the water. If we get a deposit on that probe or it's fouled, it's not going to read accurately. But I do have a policy on high conductivity. if in doubt, blow it out. You know, it's going to be a short-term loss of energy when we skim or blow down aggressively, but ultimately we need the boiler to stay online. It's not unusual to get extreme fluctuations in your water level and have low water trips if conductivity goes beyond our limits. So just this week we had a technician starting up a boiler, and they boiled it out and the boiler was clean, but putting steam into the system, which had been down for a little while, brought back a lot of garbage from the system. So they were getting low water trips all over the place. We had to measure the conductivity, and it was high from those solids coming back. He did some aggressive blowdown, and that remedied the situation. So if you don't have a surface skimmer, you may have to do more aggressive bottom blowdowns at intervals to keep that conductivity in line.